This video is going to go over significant figures, also known as Sig Figs. Sig Figs indicate how precise a measurement is and its confidence. Essentially, that means when you look at a measurement that's been recorded, you can tell how much it's estimated and how much confidence you can have that the value represented is close to what you should be expecting, or if it is more of an estimate. The first important thing to note about Sig Figs is that anything that is not zero is significant because it was a measured value. So any non-zero digit, 1 through 9, will always be significant. Continuing with this, that means zeros are the only thing that might be insignificant. So there are a few rules that we will go over to figure out when zeros count as significant and when they don't, and what the importance of that is. So firstly, if we have a zero that trails a non-zero, then it is going to count if a decimal is present. So what does this mean? We have 3 examples listed on this arrow, all of them 400, but there's different confidence in how these numbers or measurements were recorded. Firstly, we know that all of the 4s represented here are significant. I'm going to color them in green to kind of indicate that we are counting them as significant figures. Because they're non-zero, they definitely count. They were part of the measurement. Then that leaves us with the zeros. Notice all of these zeros trail, meaning they're coming after the non-zero digit, in this case 4. They're going to count as sometimes. This is kind of our sometimes rule. So they count if there's a decimal present. So in the first example, 400, there is no decimal, meaning these 2 zeros do not count as significant figures. And I'll explain the difference between the recordings of these measurements and what they signify in a moment. However, in the next example, there is this decimal. And because of that, even though it looks pretty much the same as the number above, these zeros are meant to count. And then lastly, again, because of the presence of a decimal, these zeros will also count. So in this first example, there would be 1 sig fig. This one would have 3 sig figs, and this one would have 4 sig figs. Now, why are they different? Well, they're indicating a better instrument was used when we have more sig figs. In the first number that has only 1 sig fig, all we would know based on that information is that it is closer to 400 than it is to 0 or 1000, meaning the markings are going by 0, 1000, 2000, 3000. And so the water line looks a little like 40% of the way between the two things. So we don't know more confident than that. We just are estimating that it's about 400. In the next example, where we have 3 sig figs, we have a better measurement tool. Here we would know that it is closer to 400 than it is to 390 or 410. And so that kind of means that our narrowed gap for measurement is more precise. And then even more precise for the next one, we would know that it's closer to 401 than it is 399. So every time we're adding sig figs, we're essentially shrinking the range of our uncertainty. Continuing on with our rules, that trailing rule tends to be the hardest for students because they want to say that trailing means that a decimal has to be trailing the zeros, but that's not what the rule means. It means if a decimal is present anywhere and you have zeros that trail. So oftentimes students will look at these zeros once we get into more rules and say, oh, they don't count because they're not trailing the decimal. But that is not the rule. The rule is that they trail the non-zero and the number contains a decimal anywhere. Again, the hardest rule because it's a sometimes rule. But the next rule is going to be our never rule. So if we have the 0 and it leads up to the non-zero, then it never counts. And the reason for this, so if we look at these zeros, these don't count. This doesn't count. The 4 still must count because it is not 0. The reason that leading zeros never count is because they're not actually part of the measurement. They're telling us the size of the measurement, in this case, that it's a pretty small measurement, that it's less than 1. But the actual measurement starts at the 4. So anything from the 4 and forward, if there were other numbers there, would be part of the measurement itself. But the scale is kind of represented by the leading zeros. But they're not significant because they're not part of the measurement. They're just telling us where the measurement starts. And then the last example here is center. If the 0 is centered, between two non-zeros, then it always counts. So essentially we have a sometimes never always rule situation. As I said, 4's not 0, must be significant. The 0, because it's in the middle, has to be part of the measurement. It's not an estimation at the end, so it has to count because it's trapped in between non-zero digits that have been measured. So in this example, we would have 1 sig fig. In this example, we would have 3 sig figs. Okay, I'm going to do one example with you, and then I'll have you pause the video and try to do them on their own. When you're looking at example, the main thing you want to focus on is zeros. Looking at this first example, I see a 6. I see a 3. I see a 2. Those are non-zero, so they have to count. So non-zero, non-zero, non-zero. Looking at the last thing, which is a 0, I need to decide what kind of 0 it is. In this case, this is a trailing 0. Specifically one that has a decimal in the number, which means it will count, making this a total of 4 sig figs. I want you to go through same way and kind of identify the types of zeros you're looking at and decide how many sig figs you think each number contains. So take a moment, pause the video on your worksheet, see if you can try to figure the rest of these out, and then we'll go through them together. The next number you should have identified as having 2 sig figs. These are both trailing zeros, but notice there is no decimal in the number, so these will count, these will not. This one should have 4. Obviously, all the non-zeros count, and then this is a center 0, which means automatically counts. This one has 3 sig figs. There are leading zeros here, which, as we know, never count. Non-zeros, which always count, and then a trailing 0, which has a decimal point in the number, so also counts. Here, non-zeros definitely count. These are both trailing zeros, but again, a decimal point exists in the number, so they both count. Remember, it's not where the decimal is, it's just that it is there at all. And then lastly, we should have 4. We have all types of zeros here. We have leading zeros, which never count. A center 0, which always counts, as well as our non-zero numbers. And then finally, we have our trailing 0. And again, a decimal point exists in the number somewhere. And so that counts. So hopefully this helped make sense a little bit of sig figs. The main thing to focus on in sig figs is zeros. And if you kind of learn the rules here, there's a little acronym to help you with, here we go. TLC DNA, that's kind of the little acronym, but really, this is your never rule here. This is your always rule. And then this is your sometimes rule. The sometimes rule is the hardest. If you understand the never and the always, then you just have to make sure you're really clear on when the decimal point will make zeros count in what capacity. That is all.